Welcome back to our system design series. Today we are going to explore an essential concept for building reliable and scalable systems: stateful versus stateless design. Understanding the differences between these two approaches is crucial for designing systems that can effectively handle different types of workloads and requirements. So let's try to go to an example so we can understand what these terms are. So let's say that let's start with the stateful design. Let's say that we have a client, and this client is connected with the our application or our server, and our server has a storage. Let's give it different, like store storage. Okay, so let's make the client wider. So, in a stateful design, the system remembers the client data from one request to the next. It maintains a record of the client's state in the storage, which can include information such as session data, transaction details, or any other context relevant to the ongoing interactions. In stateful system, the server keeps track of the client's progress throughout the session. A common example of a stateful design is an online banking application when a user logs in. The server creates a session and remember the user as they navigate through different pages, like transfer monies or view account balances. This makes the experience more seamless for the user, and the server keeps track of the user's current state. The pros and cons of the let's talk about the pros and cons of the stateful, and first start with the pros. It's a user-friendly experience because stateful design provides a smooth experience for users as the server can remember their actions and provide a seamless interaction. Also, it's a simple and simplified client logic. The client doesn't need to include all the necessary context with each request, as the server maintains the state, making client-side logic quite simpler. In terms of the cons, basically, we have some sort of scalability issue since the server must maintain state information. Scaling a stateful system can be really challenging. Like load balancing becomes more complex because the user session must be consistently directed to the same server. We can solve this by using like a distributed storage, like a Redis or something like that. This we can solve it, but it's still really complex. The second thing, we have some sort of single point of failure. Like if the server holding the user state fails, it can lead to a session loss, disrupting the user's experience. Also, we can solve this by making the storage distributed database like Redis or something like that. So if the server went down, any other server can basically take the storage from the server. In the stateless design, what we do, we just delete this. We have just client and application, or client and server. In stateless design, each request is treated as independent transaction. The server does not store any information about the client's state between requests, which means that each request must contain all information necessary to understand and process it. The server processes the request, sends the response, and then forgets about the client. A good example of stateless design is the typical RESTful API, which when a client makes a request, it sends the necessary information such as authentication tokens and parameters, so that the server can process the request without needing any prior context. Each request is self-contained, and the server does not retain any memory of past interactions. The pros of this one: first, we have easier scalability because the stateless systems are much easier to scale because there is no dependency on maintaining state. Load balancing is simplified as any request can be handled by any available server. The second thing, also, it's fault tolerance, because since the server does not store client specific state, there is less risk of data loss. If a server fails, requests can be routed to any server without impacting the user experience. The cons of this: we have increased client complexity because the client must send all the necessary context with each request, which can lead into increased complexity on the client side. The second thing, we have a repeated data transmission because since each request must include all the relevant information, there is potential for increased data transmissions, especially for repetitive actions. So let's try to answer the question: when, oh, wait a minute. Basically, when to use what? And we have stateless, and we have stateful. Stateful. Okay, so use stateful design is ideal for application where maintaining a session is important for user experience, such as online banking, e-commerce checkouts, or multiplayer games where continuity is critical. Use stateless is best for systems where scalability and resilience are priorities, such as web APIs, microservices, and content delivery systems, where each request can be processed independently. So that's it for this video. I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss any video. And see you guys in future problems.